Guys, so today we're going to go over a couple of concepts in 401 and 402. The first one is DMS, which stands for degrees, minutes, seconds. You may have seen this type of format. So you will have to convert it, and you'll also have to convert it before applying it to a problem. So I just want to show you first how to calculate this using a scientific calculator. So if you have this TI-30XA, you would type in 30 and then point to notate the minutes, which is 50. And from there, you would type second and plus. So second and plus, hit equal, and you should get the answer. And the reason why we go to second and plus is because above the plus sign, you will see DMS to DD, which means degrees, minutes, seconds to degree decimal. So from here, if you're using this calculator in blue, you would type in 30 and the button below, so 1, 2, 3 up top and 1 below, you'll see the degree symbol, hit that, and then 50, you'll go to that same button and you'll have to use the arrow key in order to notate the minutes, and from there, you'll type in equal, and for both calculators, you should get a final answer of 30.83 degrees, sorry. If you're doing this by hand, just a couple of things to note. So there is 1 degree for every 60 minutes and 1 degree for every 3,600 seconds, in case you do have seconds you have to convert. So in this case, I'm going to keep the 30, and I'm only going to convert the minutes to degrees. So I'm going to take 50 minutes and create my conversion table. So there's 60 minutes for every 1 degree. And from there, I'll multiply by what's on top, 50 times 1, and divide by what's in the bottom. So 50 divided by 60 will give me 0.83. And then from there, I'll add my 30 degrees to that, because 50 minutes is 0.83 degrees. And then from there, I'll add the 30 degrees I already had with it, giving me the same answer of 30.83 degrees. So calculator, or you can do it by hand. And then in section 402, just something I wanted to note, the arc length formula. Make sure that theta, or your central angle, is in radians when you are applying this formula. So notice how in the example, the central angle given is 60 degrees. So for that, we want to convert 60 degrees into radians, and you can either use your unit circle or multiply by pi over 180 to convert it. And if I convert it, I'll reduce this, giving me 6 over 18, which is just pi over 3. So now that my angle is in radians, I'm going to use the arc length formula, S equals theta r. So S equals to pi over 3 times 2, fraction form is 2 over 1, and I just multiply straight across, giving me 2 pi over 3, which is the arc length in centimeters, since the radius is in centimeters. All right, guys, I hope this helps.